Hi everyone, welcome back to our operation management online tutorial. This is the second part of our chapter about location strategy. And as you recall, for the first part, what we did was just the theoretical part, whereby we introduced what is location strategy, what are the strategies that you can use, the importance of it, and all the theoretical concept. Now, for today, what we're planning to do, we're going to do a practical part about a case study which is mainly focused on pick and pay. Now from there we are going to solve. Remember that there were three methods that we are supposed to use. The first one was the factor rating, the second one was the locational break-even point, and the third one was the center of gravity method. Now in this video we are going to solve this problem using all the three methods, and yeah, we'll take it from them. Now the case study that we have so far, as I said, it was about Pick and Pay. Now Pick and Pay in South Africa is among the biggest supermarket that are trending. Now what we do is, like in this case here, it's more like they're talking about the company that has a lot of stores in Gauteng, and then they are looking for a method that will help them to find a distribution center based on the retail shops. And also now in this part we're going to use the center of gravity method. This is what is asked in the first part of the question, but now they gave us also a map of all the locations that the location of the supermarket themselves. So we need to find a distribution center that will accommodate all the facilities. The next part is about us identifying the best location based on the factors that are given here. We have three locations. We have Elton Inn, Randburg, and Brixton. Now from here we are given all the financial statement. Actually it's something like a financial statement of the company, and based on this financial statement we should find the best location. And secondly, but this one will use the method, we'll use the locational break-even point, and then finally we are going to solve it using the factor rating. But this one here we still are doubting between three locations: Brixton, Elton Hill, and Randburg, to find which one is the best location based on the location factors that are given. Now without taking too much time, let's start with the first part of the question. The first part of the question, in short, this is only an introduction. They are saying that today Pick and Pay in Gauteng alone has seen the number of stores serviced by the Long Meadow Central Distribution Center (CDC). It has increased by 284 to 540. Now this has created a serious stress in the Long Meadow CDC. As a result, Pick and Pay has decided to open a new CDC to service the 262 stores found in Johannesburg only. Now the company chief operations officer, Ms. Naomi Morero, has identified a couple of potential areas in Johannesburg that she believes will be suitable for the new CDC. Now however, she will lack a more accurate site selection based on scientific data. She has contracted your services and has requested you to assist her in determining the location. Now Pick and Pay, the first method that we're going to use, according to what they say here, that we must find a distribution center that is based on the locations that we have here so far. So the first thing to do when you have a question like this is first of all to identify. Now because the coordinates are given on the map, you must first of all collect the data by putting them on, by arranging them in a way that will get you to solve. Now by doing so, what we're going to do is you need to draw a table that will look like this, and on the first column you identify all the stores, and after identifying all the stores, now there's the forecasted demand. This is the demand that is moving from one store to another, and this one here is already given in the problem. If you check the problem, they tell you already that these are the demand. Now the demand here for Bryanston, for example, is 560. The demand for Brightwater Commons is 213, and so on. This is the demand. This is something that is already given to us. Now the other thing that we need now to do, which is the longest part, is about identifying the coordinate. Now you look at the map, you identify, for example, Bryanston, and according to our map we notice that Bryanston has a next coordinate of 6,1, and y of 15,6. Now we go back to our map here. You look at Bryanston. We say that it was 6,1 and 16 and 15,6, which is somewhere here. We got the 6,1 and 15,6. Same applies, for example, to Pick and Pay Ferndale, which is 4,5 and 9,9 and so on. So we need to collect all this data and put them in this form here. Now the most important part about the center of the center of gravity method is the coordinate here. Those are the most important part. Now after identifying them, the other part now will be applying will be just to apply the formula. But another important part is determining the total number of units that are actually, we call them the total number of units. These one are the total number of units that are being moved from one place to another. These are the shops that Pick and Pay owns, and these are the quantity for each and every store. And the thing that you need to do, you need to take 560 plus 213 plus 332 and so on. You add all these values, and normally after adding all these values here, you're supposed to get something equal to 6,315,3. This is the total demand that you are expected. But now we need to identify now the coordinate of the center of the new distribution center, which is x and y. But this is what we're looking for now. We don't know these values here, and this is what we'll be doing in this part. So the most important part is this row here. This is the one that we'll be focusing on. Now first of all, we need to start by finding the x coordinate. After finding the x coordinate, we'll find the y coordinate and so on, and then we'll be done with this part. Now for us to find the x coordinate, the formula is simple. For us to find the x coordinate, what we will do is like we'll find, first of all, we'll take the x coordinate of the first store, we multiply by the demand of that store, plus the coordinate of the second store, we multiply by the demand of the second store, and so on and so on. And all the value that we'll get, we need to divide it by the total demand of 6,315. Now by saying so, what we'll do is like, first of all, you're working for the Pick and Pay Bryanston. So the first coordinate is 6.1 that we multiply by 560, which is the demand of that store, plus we do the same for 3,5 times 213. Then we take 2,9 times 32 plus 13 that we multiply by 321 plus 17,9 that we multiply by 621, and we have 10,1 that we multiply by 360. So these values here, as I'm saying, we are taking the respective values here. We take the coordinate, the x coordinate. Why the x coordinate? Because we are looking for the x coordinate of the distribution center. So we take 17,9 times the demand, which is 621. Now here we were on Pick and Pay Menmo, which was 10,1 times 360. Then we do the same for Pick and Pay Cresta. The coordinate is 2 that we multiply by 452 plus 7,6 that we multiply by 451, and then we take 10,4 that we multiply by 786.5. Then we take the next one is 4,5, sorry, that we multiply by 201 plus 7,6 that we multiply by 456,1 plus 12,6 after the 12,6 that we multiply by 562,1 plus 19,9 that we multiply by 452. Then we have 13,15 that we multiply by 321 plus actually this is the last one, what have I done? So we have 19,9 that we multiply by 4, 2, and then we have 13,5 that we multiply. So there are two 19,9. We have 19,9 again that we multiply by 236,5. Yeah. So this is the first part. This is how we found the x-coordinate of these values here. Then we divide everything, as I said, by this total demand of 6. The total demand is 6,315,3. In short, how you have found this value, as I explained before, it's you taking the total demand here, you add all these values, and after doing so, you're going to get this value here. Then after taking this value here and you divide, you are going to get an approximative value of 10,44. This 10,44 here, this is the coordinate, the x coordinate of the distribution center. Now we need to do the same for the y coordinate for the distribution center. Now how do we do so? The formula, the principle is still the same, but the only difference now is like we are going to take the y coordinate instead of the x coordinate, and you will notice that the demand is still the same. Like for this one here, on the first part we use the x coordinate that we multiply by the demand. Now to find this other part, we are going to find the y coordinate, we are going to work with the y coordinate that are here. So we have 15,6 for the first one, 15,6. This is the coordinate of the first one. Next we have 10,5. We have 10,5 here. After 10,5 we have 5,6. I insist on the fact that the demand doesn't change. The only variable in this calculation here is only the coordinate. So after the 5,6 we have 0,7. After 0,7 we have 8,4. After the 8,4 we have 12,5. So for recall, if you lost, we're still on this part here. We are done with Pick and Pay Benmore. Now we're going to Pick and Pay Cresta. Pick and Pay Cresta was here, and Pick and Pay Cresta was 350. It seems like I made a mistake somewhere. Let me check back. So we have 15,6, 10,5, 5,6, 0,7, 8,4, 12,5, and then yeah, we are on Pick and Pay Cresta here, which is 7,3. So you have 7,3 here. After 7,3 we go on Pick and Pay Bramfontein, which is 0,6. After 0,6 we have 15,3. After 15,3 we have Pick and Pay Fendel with 9,9. After 9,9 we have 0,6 that comes from Pick and Pay Campus Square, and after we have 4.5. We have 4.5, and after 4.5 we have 1.9. After 1.9 we have 7.9. After 7.9 we have 1.9 again. The 1.9 is for Pick and Pay and Primrose. The principle is the same. The total demand is still the same, is 6,315,3, and then we divide, and after dividing, the value that we'll find is an approximative value of 7,42. Now the 7,42, the 10,4 and the 7,42 will be the new coordinate now, the new coordinate of our distribution center. What does it mean? It means that if Pick and Pay needs to make to build a warehouse or a distribution center, according to the map, they must build something that is at 10 and 7. They must build something that is here. At this point here, it means that if they build something here, it's a warehouse that will be able to accommodate all the stores. So it will be easy to move the merchandise from the warehouse to the different places, because in short it's a distribution center. So according to the map, it's somewhere that should be in around Park Center, I mean somewhere here. Now this is the distribution center method, and the final answer in this case for the distribution will be 10,44 and 7,42. In short, this is how you solve the first part here about the distribution center. Now, thank you so much. What we're going to do is we're going to solve it now. The second question. The second part is about the factor rating method. Now, the factor rating method in this case here, sorry, this one is not a factor rating method. It's a locational breaking point, I think. Yeah. So this one is the locational breaking analysis. This one is a factor rating, and this one here is the locational. Sorry, it was a mistake. Now, from this one here, the importance of this method here. First of all, let's go back to the question. The question is saying that now we have this location here. We have the location that is Elton Hill, Randburg, and Brixton. Now they tell you that she's the operation manager is doubting between these three locations based on the cost. Now when it comes, for example, to the Elton Hill, we have a rent, an annual rent that has this value. We have the salary of the permanent staff, which has this value, and we also have the delivery cost per unit, the overhead expenses, the holding cost per unit, and so on. So these are the values that we have. Now the question that is asked to us is like, based on the information provided above, you are expected to provide a detailed locational break-even analysis for Mrs. Morero, which will indicate the following. First of all, we need to find the volume that will make this location equally attractive and the associated cost, and the favorable location for an expected volume of 63,000 somewhere here. This is the number of people that we need to accommodate and we need to find. This is not the number of people, I mean the number of cases per annum that we need to find. So it's 631,000. Now these are the number of people, these are the number of cases that we need to accommodate for the second question. Now let's go back to our first part here, the locational break-even analysis. Now on this part here, what we need to do, first of all, I should remind you first of all that the locational break-even analysis always focus, it's always about the total cost. So we'll know that this location is better than this one if it provides us with the a total cost that is low. In short, as an operation manager, the only thing that we are that you are required to do is to minimize cost and maximize profit. So any location that will have a total cost that is lower than the others is the best location. So in this case, we have the total cost. This is the total cost that we'll be looking for. Now remember that the formula of the total cost is the fixed cost plus the variable cost times the number of units that we'll be manufacturing, for example. But now the biggest problem here is about identifying what is a fixed cost, what is a variable cost. A fixed cost is the cost that do not vary. In short, it's fixed. It like, for example, your rent in this case. The rent is a fixed cost in the way that whether you produce or not, you still have to pay the rent. If you are renting a house somewhere, whether you are living inside your place or not, as long as the lease says it's 12 months and you are on the second month, you still need to pay. Now the variable cost now is a cost that varies. For example, in case we have prepaid electricity. Now prepaid electricity, for example, the cost will change in the way that if I spend 15 days using, for example, my geyser on, I won't pay the same amount as someone who spent 15 days without geyser, for example. So it's a variable cost in short. And the number of units, this is in short the number of units that you manufacture and so on. Now we must be able, in this case, what we need to do is like the question that they're asking us is to find, based on the information provided, you're expected to provide a detailed locational break-even analysis for Ms. Morero, which will indicate the volume that will make all these locations equally attractive. So the next thing to do is to identify, first of all, what is a fixed cost, what is a variable cost for all the locations that you are working with. First of all, the first one is the Elton Hill, and after the Elton Hill we have the Randburg. This one. So let me just put like here we have the locations, and after we have Elton Hill. After Elton Hill we have Randburg, and after Randburg we have Brixton. Now the thing that we need to identify here first of all is what is the fixed cost, and in this case what is the variable cost. Now the fixed cost, these are the fixed costs here. For Elton Hill the fixed cost will be 6,250,000 rand. This is, first of all, remember that what will involve our fixed cost in this case here, it's only the annual rent and the salary. Why do we say that the salary is a fixed cost? When you have a company, for example, and you have 2 employees, 3 or 4 and so on, and you pay each one of them 4,000 per month, whether you produce or not, you still have to pay the rent. You won't come up with, sorry, like we didn't produce and we won't pay you. Normally the salary is always something that is fixed, because whether you produce or not, you need to pay. So for the location, for the Elton Hill, you'll notice that the fixed cost will be 6,250,000 plus our value that we have for the salary, which is the 750,000 here. And next we do the same thing for the Randburg, which is 2,650,000 plus 750, which is the annual salary, and then we have 1,250,000 plus the 750,000 here. So here we have 2,650,000, 750 and so on. So yeah, I don't know if everything is right here. We have 250 and 75,000. Yeah, so we need to add 1 0 on the other side. Now that we have these values here, the thing that is left to do is about us identifying which the total, the fixed cost. So now from now we have 6,000 to 50,000 plus 750, and then it gives us an average 7 million. And then here we have 265 plus 7. Here we have 3,400,000, and then here we have 1,250,000 plus 750, 75,000. Now here we get 2 million, and on the other one is 2 million. On the second one, on the Randburg, is 2,650,000 plus 750,000, and we have 3 million. So there's 1 0 that is missing here. Yes, now this is the fixed cost for all this relocation. Now the remaining here, because they are saying per unit, it means that it's something that varies. If, for example, on Elton Hill we are paying 0.23 to deliver one product. If we have 10 of them, we'll take the 0.23 that we multiply by 10 and we get 2.3. So you notice that it's something that varies. The delivery cost and the overhead won't be the same. Now in this case, the delivery cost, in this case the variable cost will be the sum of the delivery cost plus the overhead plus the holding. For Elton it will be 0.23 plus 0.17 plus 0.45. Next, for the Randburg location we have 2 plus 2.65 plus 0.55, and we have our value here. And the third one is 2 plus 3 plus 3 again. Now the total cost of the first one will be 0.23 plus 0.17 plus 0.45, and it gives us 0.85. Now the second one is 2 plus 2.65 plus 0.55, and this really gives us 5.2. Let me check again the first one. Yeah, now the third one will be 3 plus 3, which is 6 plus 2, which gives us 8. Now the values that we have here, sorry to forget the unit, they are in rand because it's monetary value. So here there are costs that are in rand. Now this one we have rent, and we have rent here again. Now since we have the fixed cost and the variable cost of all the 3 locations, the only thing that is left to do is to solve the problem, which now becomes a bit more easy. Now what they want us to do, they say that we need to find, first of all, we are solving the first part of the question, which is 1 year. They say that we need to find the location. According to what they are saying, they're saying that we need to find the value at which is 1, the volume that will make all these locations being attractive. So we need to find the value that will make Elton and Randburg attractive, Elton and Brixton attractive, and finally Randburg and Brixton attractive. So the first one is Elton Hill and Randburg. So we'll find the value of X, or the number of units to be produced, that will make all these 2 locations attractive. Now first of all, what we need to do is like we'll make equations. We find the total cost. It's more like they are saying that the total cost of Elton X and the total cost of Randburg must be the same, so that all the location will be equal, the 2 locations will be equally attractive. Now in this case, to find the total cost, remember what we say, Elton total cost will be first of all the 7 million that we need to, which is the fixed cost, plus the variable cost of 0.85. But now remember, there's the number of units. We don't know how many units we should produce. Then we multiply times X, which is equal to Randburg. Now Randburg, according to what they're saying, our volume, according to what we got, our volume is 3,400,000 that we must add with our variable cost of 5.2, and we also don't know how many units we should produce. In short, we're looking for that number of units that will make the 2 locations equally attractive. Now in this case here, we need to make X the subject of our equation. If we need to move all the values with X on one side, we'll get 0.85x minus 5.2x. that will be equal to 3,400,000 minus 7 million. Now we are going to get a negative value of 0.85 minus 5.2. Now the value that we get here is a negative 4.35. This is X, and we have our 7 million here minus 340, and we have a value of 3,600,000. Now this value here is negative. Now what we do next is we divide both sides by a negative 4.35, so we get X on this side, and we get 3,600,000 that we divide, it's a negative 1, that we divide by 4.35, negative 4, we divide by 4.35, and the answer that we get is 827586,20 or 21 in short. These are the number of units. These ones here, they are the number of units that will make Elton and Randburg equally attractive. But now we must notice we must also specify something, that this number of units that we'll find here, they are only related to these 2 locations here. But what will be the total cost now? The total cost is us taking this number of units that we can replace in either one of these equations. We can replace it in the Elton one, or we can replace it in the Randburg. It won't change anything. The value will still be the same, because we assume that this is the value that will make all these 2 locations equally attractive. Now what we do is like we replace it in the Elton formula, and the value that we will get times 0.85 plus 7 million. The monetary value that we'll find is 77 0.3 I mean 0.344 8,28 and so on. So this is the monetary value that we'll find. In this case, this is the total cost that we'll find if we make this amount of unit here for these two locations. Next, what we'll be doing now is to find the location between Elton and Brixton. So we do the same for Elton and Brixton. Now, to find the location for Elton and Brixton is still the same. We need first of all to find the total cost of Elton, which we already found in the first part here. Now we need to do the same for Brixton. Now when it comes to Brixton, our total fixed cost was something like 2 million that we need to add. Now we need to add our 8 rand, which is the variable cost that we multiply by x, which is an unknown number of units that we need to make. We do the same thing now. We make all the values with x on one side, which will be equal to 2 million minus 7 million. And then here we get a negative value of 8 minus 0,8. We get a negative value of 715. X, that will be equal to 5 million. And then if we divide all the value by negative 7,15, we will get negative. By the way, this one is a negative 5 million. Sorry, I forgot. So we get a negative 5 million here that we will divide by our negative 7,15. So I get our 5 million that we divide by the negative value, and we have a value of 699,300, and then we have 70. These are the number of units again that we will need to. These are the number of units again that we'll need to use so that Elton and Brixton will be equally attractive. Now in this case, we need to calculate again the total cost. Now in this case, I'll take for example Brixton. This is the equation to find the total cost, and then we'll replace the value of x by the monetary by the number of units that we produce here. Now in this case, we multiply this value by 8 plus 2 million, and the value that we get is 7594405,59. So it's 7594405 and so on. I want to mention something, that when you'll be calculating, if you are calculating with me, you'll notice that sometimes this value we are working with decimals, and I decided to take 2 decimal places, which you'll notice that sometimes the answer won't necessarily be the same, because we are rounding off everywhere where that you're working. If you take the full numbers that you get on a calculator, you are going to get the accurate value. So these values might vary according to the number of units that you take and so on. Now finally, we did the number of units that will make Elton and Randburg equally attractive. We made also Elton and Brixton, and the only one that will be left will be now Randburg and Brixton. Now we need to calculate the total number of units that will make Randburg and Brixton equally attractive. Now, what is our equation of Randburg? The equation of Randburg, we already found it in the first part, which is this. And then this equation must be equal to the equation of Brixton that we took here with 2 million. And this equation will give us 5,2x minus 8x, which will be equal to 2 million minus 3.4 million. It's 3.4 million here, which is 3,400,000. Yeah. Now, by doing so, we get our value of 8 and 5.2, which gives us a negative value of 2.8x. That is equal to our value of 3 million minus our 2 million, and we get a value of 1.4 million. Now this one, sorry, again, it's a negative value, I'm still forgetting. Now we need to divide. If we, to make x the subject of our equation, we divide both sides by negative 2.8. We have 14, then we have 0. Yeah, we divide it by negative 2.8, which gives us, we divide by 2.8, which gives us a net value of, an exact value of 500,000 units. And this is number of units that we'll need to manufacture here, unit. Now again, we do the same principle. We need to find the total cost. Again, for the total cost, we can still take these values here, I mean this equation, the equation of Randberg, and we replace it by 500,000 units. Now by doing so, we get this value here that we multiply by 5.2 plus 3,400,000, and we get a value of 6. 1, 2, 3, 4. We get a value of 6 million. So we have 1,400. Let me just check something. So the value that we got, which was 8 minus 5.2, which gives us 2.8, and the 2.8 that we divide by 1.4 million, and we got the 5,000. The 5,000 that we replace in our equation of 5.2 plus the 3,400,000, I'll get 6,000. Okay, so this is the monetary value that will make, Randberg and Brixton equally attractive. Now, having found these values here, we're done with the first part, which is about Hilton and Randberg. Now the second part that we need to do is, what is the question saying? The question is saying that we need to identify the favorable location for an expected value of this number of units here, the one that I just highlighted here, per annum. So this is, in short, is more like they say, what if they need to manufacture this number of units here? Best location for this value here, unit. So the best location, in short, will be the location that will have the lowest, how do we call it? The location that will have the lowest total cost. Sorry. Now the location that will have the lowest total cost, first of all, we start with Hilton, and then we'll have Randberg, and after Randberg we have Brixton. So we have Hilton. After Hilton we have I think Randberg. After Randberg we have Brixton. Yeah. Now from here, what do we have? So what do you have from here? What is the equation of Hilton? This is the equation of Hilton. What have I done? Yeah, this is the equation of Hilton, and we put it back here. And after we have Randberg, what is the equation of Randberg? This is the equation of Randberg. And finally, we will take the equation of Brixton. And the equation of Brixton here, it is. Now everywhere that we'll find an x, we need to replace it by the number of units that has been given to us here. So we replace x by this value replace it by this value, replace it by this value here. Now for the first equation of about Elton, we have 631530 times 0.85 plus 7 million. The value that we get is 753680 times 5, sorry. The second is 631530 times 5.2 plus 3.4 million, and we get 6683956. And the last one, it was 6683956, 6683956. And the last one now is 631530 times 8 plus 2 million, and the value that we get is 7052240. Now this part here shows that because we have these three values here, the total cost, it means that if we need to go to Elton, we'll have to pay an approximately cost of 7 million and so on. If we need to go to Randburg, it will be 6 million, and if we go to Brixton, it will be 7 million again. So the best location in this case will be Randburg because it has the lowest total cost. It won't cost as much to have a shop there because we are going to pay only 6 million. Now this is all about the second part about the locational break-even analysis. Now the last part of the exercise now is about using the factor rating. Now using the factor rating, this one is a bit similar with what we did in the first part. Now we are given locational factors. These locational factors here, normally when you are conducting your study, for example in a specific area, those are the things that you must look like, maybe the work ethics, the quality of life, the labor laws, and so on. And then you give them a specific weight. After identifying this specific weight, now you start rating them. And like this one here, the scores goes from 0 to 100. For example, they are saying that from 0 to 100, Randburg says that we give it 70% when it comes to the work ethics, for example. When it comes to the quality life, we gives it 95%, and so on and so on. So this method is a bit easy. What we do, we take our weight. For the first factor, which is the work ethic, for example, we take our weight of 0.8 plus 80, times 80 plus the 0.16 times 75 plus 0.12 times 90 plus 0.18 plus 60, and so on and so on. So we'll do the same for Brixton. After Brixton, we go to Elton. This one is a spelling error. We go to Elton. After Elton, we go to Randburg, and so on, and then we select the location with the highest value. Now when it comes for example to Brixton, what we do is that we take the weight of 0.02 that we multiply by 80 plus 0.16 that we multiply by 75 plus 0.12 that we multiply by 90 plus 0.18 that we multiply by 60 plus 0.08 that we multiply by 80 plus 0.07 that we multiply by 75 plus 0.06 that we multiply by 70 plus, actually the factor that we're doing so far is cost of living. That goes with this, the one that we just finished now, that goes with Brixton. Now we need to do the taxes, which will be 0.06 that we multiply by 65 plus 0.05 that we multiply by 90 plus 0.03 that we multiply by 45 plus the one that we were doing was the government regulation. Now for transportation is 0.18 times 90 plus 0.02 times 90, and finally plus 0.02 again times 60. Now the value that we get after adding all these values here will add up to 75.5. This is for Breakstone. Now this is the weight of Breakstone here. We need to do the same method for Elton and Randburg and so on. Now analytically, when you guys would be doing it, you'll notice that when it comes, for example, to Elton Hill, you'll find a value of 71.95. When you do for Randburg, you'll find a value of 76.06. So you can check it by taking, again, for Elton, you take 0.02 times 90 plus 0.16 plus 85 times plus 0.12 plus 60 and so on. For Randburg, you do the same thing. You take the relative weight of 0.02 times 70 plus 0.16 times 95 plus 0.12 times 60 and so on. Now based on the result that we get here, you notice that Breakstone is 75.5, Elton is 71.95, and finally Randburg has a value of 76.05. Now in this case, we are going to take the highest value that weighs the most. So in this case, it will be Randburg, and Randburg will be the best location. Now based on this question here, having said that, this is all about location strategy, and I hope that this tutorial was really helpful. If you have any problem, you can contact me via email and then we can talk. So thank you so much for your time and enjoy your evening. Bye.